So as I told you earlier, there are 6 co-channel cells which is assumed in this particular system, and we need to ensure at least minimum 15 dB signal to interference ratio, and correspondingly we need to calculate the reuse factor Q as well as the cluster size capital N. So we have two cases to analyze. One is n equal to 4 case and another is for n equal to 3 case. So first we will go for n equal to 4 case. And since in the given question it is assumed that there are 6 co-channel cells. So first we will take cluster size as n equal to 7 and we will see whether this can be allocated or not. Or else we will go for n equal to 12 like that. Okay. So first we will see n equal to 7. So when you take n equal to 7, of course the quality factor or the reuse factor that you have is d by r, which is equal to root of 21, that is 4.583. And based upon this Q, you will find S by I ratio, and the S by I ratio is root 3n the whole to the power n divided by I0, that is 4.58 the whole to the power 4 divided by 6. Why it has come 6 over there? Why it is coming 6 over there? Because you are having 6 co-channel cells mentioned in the question. Okay, and you will find the value, that is 75.3, and you will then apply 10 log so as to convert into dB. So you will get 18.66 dB as the answer. So this is very much greater than 15 dB. Our condition is at least 15 dB signal to interference ratio you need to maintain. But when you take the cluster size as 7, okay, when you take the cluster size as 7, you already got S by I ratio as 18.66 dB, which you can finalize, or this is okay for us. 18.6 dB is greater than minimum SIR required. Therefore, we can claim that n equal to 7 can be used for this particular case. What is the case? For small letter n equal to 4. That is the path loss exponent is 4. Any doubts with respect to this? I have assumed n equal to 7. If this was not satisfied, means I should go to some other factor, like 12 I have to take. You can't take n equal to 8, 9 and all. You have the logic now. What is the value, what is the equation of determining n? N is equal to I square plus ij plus j square. You have to revise those portions. Okay, without revising the portions, you won't be able to understand all those things. So n equal to I square plus ij plus j square, which I have already taught you in the previous 2 classes before. So accordingly, you need to suggest n. Okay, if I and j both are 1, means 1 square plus 1 into 1 plus 1 square, n can be 3. If I and j are 1 and 2, means what will happen? 1 square plus 2 plus 1 square, isn't it? Sorry, 1 square plus 2 plus 2 square. So in that case, you will get 7. If you take both 2 and 2, means what will happen? 2 square plus 4 plus 2 square, that will be nothing but 12. So you can't randomly take 7, 8, 9 and etc. After 7, the only possibility that you can have is 12. So you need to put the values of E and J. Accordingly, you are going to assume the cluster size n, whether it is applicable for our case or not. Coming to case B, what is case B? For n equal to 3, we are going to see if the conditions can be satisfied or not. Again, we'll go for n equal to 3 and again we'll take n equal to 7. Capital N, we will assume it as 7 itself. If capital N equal to 7, it is understood that Q is 4.583, because from the previous case already we have, when you take capital 7, capital N is 7, then the quality of the reuse factor is root of 21, that is 4.583. That you will substitute over here and you will find S by I ratio. The only difference is instead of 4, you will have 3. So 4.583 whole to the power 3 divided by 6, that is 12.05 dB. Actually, it is 16.04. Then you will convert into dB. How? By taking 10 log. Okay, the answer is 16.04. Now you need to apply 10 log. So you will get 12.05 dB, which is less than 15 dB, which is not appreciable. Because in our condition, we have been given that at least you need to ensure 15 dB SIR. But unfortunately, if you take this capital N, that is cluster size as 7, you are getting only 12.05 dB, which is less than the minimum value. So we cannot take N as 7. Now after 7, I will take 12. The only possibility after 7 is 12. 3 is okay, 7 is okay, then it is 12. Okay. I square plus ij plus j square. If you take I and j as 2 and 2, then 2 square plus 2 into 2 plus 2 square. That is 4 plus 4 plus 4, that is 12. So if you take n as 12, then the quality factor that you get is 6. If you take n as 12, then the d by r ratio that you get is root of 12, that is 6. Okay, corresponding to this value, you substitute and find the s by I ratio. The answer will be root of 3n the whole cube. Why it is whole cube? Because it is given that n is equal to 3. You need to calculate for n equal to 3. Clear? So 6 cube divided by 6. Why I0 is 6? Because it is given in the question that there are 6 number of co-channel cells contributing the interference. So answer is 36. Apply 10 log and find it in dB. So answer is 15.56 dB, which is greater than 15 dB. So we can use cluster size as 12. So for same parameter, when the exponent factor or the path loss exponent n equal to 4, you are using the cluster size as 7. But when the path loss exponent is 3, you are using the cluster size as 12. So accordingly, when you change the cluster size from 7 to 12, correspondingly, your signal to interference ratio will vary, and the system designers have to ensure that they need to select appropriate value of cluster size so that the signal to interference ratio is greater than the threshold minimum requirement. Okay, if minimum requirement is 15 dB, we need to maintain SIR value greater than 15 dB. Accordingly, you are going to select the value of capital N. So with the trial and error, you will put 7, 12 like that, and you will see whether S by I is greater than 15 dB or not. So from this problem, it is evident that the quality of entire system depends on cluster size as well as the path loss exponent. Because for small letter n equal to 4, the cluster size required was 7. 7 was sufficient. But for n equal to 3, you need to increase the cluster size to 12 so that only your SIR is increased to, you can maintain your SIR more than 15 dB. Otherwise, if you are continuing with the same cluster size, it is evident that your SIR has gone below 15 dB, so that is not appreciable. So you need to extend or increase the cluster size from 7 to 12 to get more SIR or to get the appreciable or the required SIR which is greater than 15 dB. Is it clear for you? Any doubts, please ask. Any doubts you have? And how you are going to fix capital N? The equation for capital N is I square plus ij plus j square. You have already gone through that geometry, how to locate the co-channel cells. Please revise and please ask. Okay. The value of capital N is I square plus ij plus j square. You need to substitute appropriate integers for I and j. Accordingly, you are going to fix capital N. So don't go for random n and all. Only there can be discrete values of n. Okay. That is n can be 3, n can be 7. If both I and 1 can be 1 and 1, I is equal to 1, j equal to 1 means capital N will be 3. If I equal to 1, j equal to 2 means it can be 7. If I equal to 2 and j equal to 2 means it can be 12. And if I equal to 1, j equal to 3 means it can be 13. So possible values of n, you should have a list with you. Then you will go from 1 by 1, 3, 7, 12, 13 like that, and then you will see whether your SIR has approached the minimum requirement or not. According to it, that only you need to fix capital N. Is that clear for you? I'll stop here and we'll continue the class tomorrow. Thank you.